Hi, everyone. So we are on 2.1, section 2.1. This is on page 129. We're going to be just finishing this lesson. We're not going to be extending another day or anything like that. But here we go. So hopefully you took the time to read this section right here. And if you notice right here, we have something called the principal square root, right? The principal square root is the one that you normally look at when you're like, what's the square root of 25? And you're like, oh, 5. Because most people think of just the principal square root. They don't think that there's actually another solution to that, right? And even in geometry, and this is what we talked about in class, in geometry, we talk about a squared plus b squared equals c squared. And again, the answer we're only concerned about there is what's the square root of 25? We're like 5. There is another number, and somebody had thought of it, like, oh, -5 times -5 is also equal to 25. So this, the square root of 25 actually has two different answers. Okay, it's +5 and -5, right? But normally in geometry, especially, like, we don't care about the -5 because it's an irrelevant answer because you can't have a distance of -5. Like, that's never going to happen. Right? Distance is always positive, right? But in the algebra world, now we can deal with -5s, right? We can actually graph that, right? And so here we have x squared is equal to 9. So this is what it, oh, not the highlight version. So we have here x squared is equal to 9. And in order to get rid of the square, you need to square root both sides. So the inverse of a square is a square root, right? And so that's going to be, so the square and the square root cancel out. So that's why we just have the x. And then the square root of 9, well, what is the square root of 9? 3. Okay, and so the way they wrote it here is plus or minus 3, which literally means just 3 comma -3. So there are two different answers here. We're saying 3 and -3. But a lot of the mathematicians are like, well, why do we have to write 3 twice? Can we just go plus or minus 3? And so this is literally called, I'm not asking you if it's a plus or minus, is it like positive or negative? Is it a function or not a function? That's not what I'm asking. I'm just saying that it's plus and it's positive and it's negative. Why did it say plus or minus? It's a different kind. It's saying both of them. We're going to do both of these, and it could be 3 and it could be -3, or it could be -3. Okay, that's what we're saying. All right, so we always just call this plus or minus, but I'm not asking you to say, oh, it's plus or it's minus. That's not what I'm saying. Okay, so then from here, if we take a look at this, remember, so x squared is equal to 9. So this is where y is equal to 9. If you notice right here, it's at 3 and at -3. That's what x would be equal to, at 3 and -3. And then we talked about our different square roots right here, or our perfect squares, and it'd be really beneficial for you guys to know these perfect squares. It'll just help you when you reduce or simplify radicals, because you are going to be expected to know how to do that. And the first question, I guess we never answered the question here. So it says, what is the equation for the axis of symmetry, right? And what is that equation for the axis of symmetry? Well, what's the equation in general? Let's see here. It's just y is equal to x squared. So if it's y is equal to x squared, right? Well, we already know what that is. The equation right here is going to be x equals 0, right? Because it's right on where x is equal to 0. So x equal to 0. So if you look at it from the axis of symmetry, right, it's 3 to the right and 3 to the left, and that's how we would get those answers. Same thing with if we're at 4. What is the square root? What is, if y is equal to 4, what is x equal to? +2 or -2? Because 2 squared is 4 and -2 squared is also 4, right? So we're going to do some scrolling here. Only other thing to make sure you have your highlighter here. So remember, you have this parabola right here, and usually we have like 2 roots like this, 2 roots, see, 1, 2. But if it's right exactly on top of that, it's right on the x-axis, and that's where the vertex is, that's what we call a double root, because we get 2 answers. All right, so right here at 0, 0, we have 2 answers, because if we're going to solve this, and it says this right here as well, but this is going to be like our x squared is equal to 0. How do we solve for the x? Get rid of the square, so square root both sides. And when we do that, we get x equal to plus or minus 0. And you're like, well, isn't that the same thing? And I'm like, yes, it is. So, so literally our 0 happens 2 times. So 0, 0. So that's why we call it a double root. Okay, or they would say it's one unique root because it's technically just one number, right? But the answer does come out twice, right? And that'll be important later on, but not right now. Okay. All right, now on this page, what we have here is 3 functions, right? 3 graphs. The one in yellow is represents x of x squared. The pink one represents x squared plus 2, and the blue one represents x squared minus 8. And so what we're going to do, this is just a copy of the bottom right here since I couldn't put them all in one page. So if you're going to take a look at letter A, so this is x squared plus 2, right? So that represents this function right here. And so we want to know what x would be if we plugged, instead of y, we plugged in a 14. Right? So we went all the way up to 14 and we're like, okay, what would x be? Because these are all the answers. All the answers are here. So when x equal to 14, y is equal to 14, what is x equal to? Well, it looks like it's a little bit 1, 2, 3 over negative 3, 3.5 or something to that effect, right? And this is negative 3.5 and positive 3.5, because remember, if we're starting at 0, it's the same distance apart, right? Because it is symmetric. And so we're thinking maybe about we had guessed 3.4, looking like maybe 3.5. And so we're going to now solve it algebraically. And it's just like your Algebra 1 class where we just solve for x, right? So again, we're going to subtract 2 on both sides, because to undo a plus 2, we subtract 2. So we get 12. So x squared is equal to 12, and then you're going to square root both sides. The reason why we do that is to get rid of the square, all right? And so x is equal to plus the square root plus or minus the square root of 12. So whenever you square root both sides, you have to remember plus or minus, add that in. All right, and normally I would just like the answer as x equal to plus or minus square root of 12, but we want to just check if our estimation was correct, and you just plug that into your calculator, square root of 12, and we get about 3.5. So there we go. And honestly, when you do the calculator, it can't give you 2 different answers, so you just have to know that to put in the plus or minus, okay? Because when you do the calculator, it'll always do that principal square root, okay? It's just going to give you the positive. It won't give you the negative of that. All right, and then taking a look at this b, remember x squared is equal to 10. So this is where y is equal to 10. So when y is equal to 10, what is x going to be? It's going to be over here at negative 3.1, 3.2, and positive 3.1 or 3.2, right? So we had guessed in class that's about plus or minus 3.2. And sure enough, just to get rid of that square, we're going to just square root both sides, and that would just give us x equal to plus or minus the square root of 10. All right, and I am going to go over a few other things here. This was just to help you determine like how much is the square root going to be, right? So in class, we had talked about the square root of 50. Well, how do you estimate the square root of 50? And we just think of two perfect squares that are close to 50. And I'm like, oh, okay, I know 49 is really close to 50, right? And the way we get 49 is 7 squared is 49. And we know that 8 squared then would be 64, right? So the square root of 49 is 7, and the square root of 64 is 8. And notice that 50 is in between the 49 and the 64. So we know it's somewhere in here. So we know it's going to be 7 something, right? And the reason why we said 7.1 was because the 50 is really close to 49, and it's pretty far away from 64. So we're thinking it's much closer to 7 than it is going to be 8. So it's going to be about 7.1. And if you put that in a calculator, you'll find out, I don't remember what it was again, the square root of 50. You'll find out if you round to the nearest tenths place, it is 7.1, right? So that's how you can estimate pretty accurately where this is going to be without even using your calculator, just using your common sense. So let's try another one. This one uses 75, but we're going to use another number like, let's go square root of 30. Why not? And I'm like, well, what's close to square root of 30? It's definitely not, well, not 49. We can get something a little bit bigger, a little bit less than that. So 36 is 1, right? And how do we get 36? That's going to be 6 squared, right? So we're going to do the on the other side, then this must be 5 squared, right? Because it's not going to be that big of a jump. So this is going to be 25. All right. So this is always going to be like next to each other, like in numerical order, right? This one's 6, the other one is going to be 5. Like here, this was 7, the other one's going to be 8. right? And what is the square root of 25 and what is the square root of 36? 5 and 6, right? And we know that 30 is about 5 away from 25 and 6 away from 36. So it's like pretty much in the middle. So I'm thinking it's going to be around 5 point, but a little bit more towards the 5 as opposed to the 6, maybe 5.45, right? Let's find out. So square root of 30. Oh, not terribly bad. So this is, what does it say right here? 5.448. So I get 477 something, but yeah, about 5.48. But do you see how we got pretty close? So yep. So that's how we would do, that's how you estimate it. Do you need to know this? Is it a must? No, you don't, but it's nice for just some number sense to kind of figure out. If your calculators, if you put in square root of 50 and you get like 10.7, you're like, oh wait, that doesn't seem right. And then you know, oh, you must have put something wrong in the calculator, right? Just for your estimation of what it should be around. Okay, and now this is the stuff that you really, really need to know. Okay, you need to know how to simplify these guys. So this is what we're going to call simplify radicals. Simplify radicals. Okay, and we're going to need this for our answers later on when we're finding the x's, solving for x, right? I do want you to put it in the simplest form. So you're always going to be simplifying radicals. So if you look at this, we have the square root of 75 here. There's a couple of different ways to do this. One of the ways is factor tree. And so if you learned this in a previous class, you could totally use that. My only drawback to this is that some people forget which ones they can use. And they're like, ooh, which one? And so remember this, the way we get this is square root of 75. How do we get 75? It's getting 3 times 25, right? Well, we can't split up to 3 anymore because it's a prime number. Well, how do we split with 25? 5 times 5. You find any doubles, right? Because those doubles are actually perfect squares, right? And that's going to be square root of 25 is going to be 5 on the outside, root 3. All right. And the other way that you can do this is the way I like to do it, just because I think for students, it's a lot less confusing. It's a little more like very clear on what needs to happen. So my opinion, not yours. So what we ask, so I'm going to just put it right here. So here's 75. We're going to kind of do like a upside down division, right? So what goes into 75? Like 3 goes in there. We're always looking for prime numbers. So 3 goes into 75 25 times. Well, what goes into 25? 5. So 5 goes into 25 5 times. And then we keep on going until we get to 1. So what goes into 5? Well, 5 goes into 5. How many times? Once. So once you get the 1, then you know you have all the factors listed out. Okay, now when you look at this guy, you're like, okay, do I have any doubles? Yes, this is my perfect square right here, 5 times 5. So that's all the perfect squares can go out. So that's 5 squared is going to be 5 root 3. All the singles stay inside, right? All right. And if you look at right here in the book, this is what they tell you. And this is exactly what we've been doing, right? So they split it up. They either used this way right here with the upside down division, or they use the factor tree. It doesn't matter. But ultimately, they know that 3 times 5 is equal to 75, right? So they broke it down. This is what we call prime factorization, right? We factored everything into just prime numbers, right? Which all numbers can be done that way. And they noticed, oh, 5 times 5, oh, that's 5 squared. And then they just broke up the radical. So the square root of 3 for 1 and times the square root of 5 squared. Now remember what I said, right? The square and the square root cancel each other. So what do we have just left? 5. So this is 5 root 3. And this is mathematically, this is the most sound. So if you want to do it this way, totally do it that way. If you can recognize, oh, 75 has a perfect square in it, 25. And what do you have left over? 3. So then if you get good enough, you can totally do it that way. All right, so we did a couple of these right here. I'm going to do C and D. So we're going to take 18 and we're going to do our upside down division. So 2 goes into 18 9 times. And what goes into 9? 3. 3 goes into 9 3 times. And what goes into 3? 3. So that's just left with 1. Do we have our perfect square? And you're like, yes, ma'am, we do. Right here. So this is, remember, this is equal to 3 squared, right? So remember, this is under a square root. So the square root of a 3 squared is what? just a 3. And then this guy still stays in the square root, so this is going to stay in home. So it's 3 root 2. So if you want to try that on your calculator and you go 3 root 2, you're going to get 4.24, right? And if you go square root of 18, again, you get 4.24. So you know you did it right. You simplified it correctly, right? Because they should equal to the same thing. Because you're not supposed to change any values. You're just changing the way it looks. It's cosmetics. All right, same thing with 116. Where's my mouse? Oh, here it is. So 116. I'm going to divide. So I know it's an even number, so definitely 2 goes in there evenly. So 2 goes into 11 5 times with a remainder of 1. 2 goes into 16 8 times. Or you can use your calculator, up to you. I like to do things in my head. So what goes into 58? Well, I know that 2 goes in there because it's an even number. So 2 goes into 5 2 times with a remainder of 1. 2 goes into 18 9 times, right? And then, 29. That is a perfect, that's not a perfect square. That's a prime number. Nothing goes into 29. So 21 goes into 29 one time. All right. And you can try all the different numbers, but you're going to realize it doesn't work. And again, do we have any perfect squares? The upper dues right here. So we have a double right here. So the perfect square is going to come out of the radical. So it's going to be 2 root 29. Okay. And some people may ask, well, what if we have 2 numbers that don't have a pair? Then you just multiply those 2 numbers. All right. That's how that goes. We're going to skip a few, 1, 2, skip a few. We're not going to talk about these parts. If we look at this part, this is on page 137. I would try and do this yourself and then maybe press play, but it's good for your brain to try and access something instead of you just listening to somebody going, oh, okay, yeah, makes sense. Just saying. Okay, so again, right here, we graph this guy. We sketch the graph, label the axis of symmetry and the vertex. So one thing we did not do was label the axis of symmetry. So let's do that right now. Our axis of symmetry is right here. And if you're like, well, how'd you get that? Here it is. See, do you see how I labeled them? So it's easy to find. So our AOS is going to be, just remember, x is equal to negative b over 2a, and which means we have to define what our a, b's, and c's are. So over here, our a is 4, our b is 0. Notice there's no x there, just regular x, there's no x there, which means it's literally 0x. And then our c is negative 9. And we're going to plug it all in, and we get 0 over 8, which is just 0. 0 divided by 8, still 0, right? So this is our AOS right here. X is equal to 0, which is the y-axis, right? That y-axis is our AOS. And our y-intercept, again, if you were going to plug in 0 for x, you would just get the negative 9. And if you're just already familiar with that, you can realize, oh, it's just this number that's out here in the back. But that's mathematically the reason why, not just because we say so. All right, so that's our y-intercept, which also is our vertex, right? Because remember, if you plug in the 0 of the AOS, the number for x, we will get our vertex. So our vertex is our y-intercept. That's it. Okay, and so we know it's there. Again, looking at the 4, the a, that is positive, so we know it opens up. So it's going to look something like this. But we don't know where those roots are. But now we can find out. We have tools for that now, right? Remember the x-intercept is where the y is equal to 0. Just like for the y-intercept, that's where the x is equal to 0. So you flip-flop. So for the x-intercepts, that's where the y is equal to 0. So we're going to just set this function equal to 0, right? And now we're going to just solve for like how we normally been doing for this whole period or for this whole lesson. So we're adding 9 to both sides. And then to get rid of this 4, you have to divide by 4. And then you're going to get rid of the square here. So you have to square root both sides. And once you do that, don't forget to add in the plus or minus. And then you're going to get x equal to plus or minus, well, what's the square root of 9? 3. What's the square root of 4? 2. So this is going to be plus or minus 3 over 2, or you could say plus or minus 1.5. Either way, 1.5 is probably more useful to us because we could actually graph a thing. So it's going to be 1.5 to the right and 1.5 to the left. Boom. Graph done. A few things that we did not finish was this green part right here. It says, use what you know about the difference of 2 squares to rewrite each quadratic as a product of 2 linear factors. Then use the zero product property to verify the values of x when f of x equals to 0. What in the world does that mean? Okay, first thing we're going to do is going to take this a, And we're going to go, what is it? F of x. Oh, this is a f of x equal to 4x squared minus 9. Do you remember our difference of squares? So the way we would do that is, okay, remember it's one is going to be minus, one is going to be plus. So what two numbers multiply to be a 9? A 3. And what two numbers multiply to be a 4x squared? Well, I know they both have to have x in them because these two have to look exactly the same. Well, then how do I get 4? I can't do 4 times 1 because they're not the same number. But I could do 2 times 2, right? So now I have the exact same number here and then the exact same number here. The only thing that is different is the plus and the minus. So this is what we call the difference of squares. This is what that is. Now it's in factored form. See, we just factored a thing. And we know that the middle terms cancel out because we practiced that all yesterday. And so now if you notice this is factored form, we do know if we're going to like work with me here, right? So if we do know that this y is going to be 0 because we want to know what the x-intercepts are, right? So what is the x-intercepts? What are the x when y is equal to 0? So we're going to plug in 0 for y, which is f of x, not just x, f of x. And then we're going to say, okay, we know this to be true. Now, here we're multiplying two different numbers. What two numbers can we multiply to get 0? And if you know anything about 0, you know, well, at least one of them has to be 0. Either this one has to be 0 or this one has to be 0, or they both can be 0. It doesn't really matter. But so what if we said this was equal to, so there are two possible answers here. So we can say, well, 2x minus 3 is equal to 0. Or we can say that 2x plus 3 is equal to 0. Okay. And either way, we're still going to get an answer. So we're going to have two different answers here, which makes sense because if you see right here, how many x-intercepts do we have? We got 2. All right, so let's just solve for x now. So we're like, okay, well, I know this part. We just add 3 to both sides. We got 2x is equal to 3 and divide that by 2 on both sides, and x is equal to 3 over 2. That looks very familiar. Why does that look familiar? Well, let's do the other one. Well, oh, before I get to that. So when x equals to 3 over 2, if I plug this back in, that's going to make this whole thing equal to 0. Okay. How do you know that for sure? Let me just show you. You don't have to do this normally, but let me just show you. So 2 times 3 over 2 minus 3 times 2 times 3 over 2 plus 3. What do you get? So this is 2 divided by 2, which is going to be 1. Right? And this is going to be 3 minus 3. And then this is going to, again, these are going to cancel out to just be 1. So 1 times 3 is 3 plus 3. Like, well, this is 0 times 6. Well, what's 0 times 6? 0. See, told you it equals 0. So it honestly did not matter what this turned out to be. We knew that since one of them is equal to 0, the whole answer is going to be 0 because we're ultimately going to be multiplying them, right? And the same thing is going to be true for this guy right here. So let's do this. Subtract 3 on both sides because it says add. So, and 2x equal to negative 3. And divide both sides by 2, and we get x is equal to negative 3 over 2. And if you notice right here, you're like, where have I seen these numbers before? This right here and this right here. That's that right here. So we solved it this way, and we solved it by factoring. And this is what we call the zero product property. Okay, what does it mean to be the zero product property? The reason why, okay, so it's 0 because we're setting equal to 0. In order for it to be 0, what does product mean? The product means the answer for multiplying, right? And so this only works if we're multiplying two expressions, right? Or two expressions. And so if you know that both of them, when you multiply it equals 0, then you can set both of those two terms equal to 0. Or two factors equal to 0. So this guy, we set this guy equal to 0, and we set this guy. So, sorry, but all right. So I got disconnected for a little bit. I was a little bit worried, but here we go. So we're gonna try the talk to talk, okay? Because we'll talk more about this in a little bit. Oh, one thing I do want to notice is that remember what we talked about here. This is being the roots. Yeah, so this does tell us what the roots are, right? And they are related to this. Okay, so we'll talk more about that a little later on. Not today, but throughout the lessons for this unit. All right, so what I would like you to do is just press pause and just do 1 through 2 and 3. 1, 2, and 3. Okay, and then once you do that, I want you to unpause and then check. All right, go. Or should I say stop? All right, so it says solve each equation. So we're gonna just solve this the way we normally would solve them, right? And so here I'm subtracting 25, so I have to add 25 to get rid of that, or to undo that. So we get x squared is equal to 25. And then what do I do from there? Gotta get rid of that square, so I'm gonna have to square root both sides, and I'm gonna get x is equal to 5, because the square root of 25 is 5. And if some of you guys are like, wait a minute, Miss Lee, I thought you were supposed to, good job. Yeah, because you're supposed to put in the plus or minus. So don't forget the plus or minus. All right, and we're going to do the same thing for b. So we're going to add 1 to both sides. And we got 4 squared is equal to 1. And how do we get rid of this 4? We have to divide that by 4. So then we get, I'm going to put it right over here. So x squared is equal to 1 over 4. I'm not going to change that into a decimal just yet, because actually we could do this. Again, square root both sides, and you're going to get x is equal to, oh, excuse me, sorry. Now, remember it's plus or minus, and what is the square root of 1? 1. Well, what's the square root of 4? 2. Because literally 1/2 times 1/2 is what? 1/4. So that's the answer right there. And now we're going to try it with this one. All right, so we're going to add 2 to both sides, and then we get 9x squared is equal to 2. And then we're going to divide both sides by 9 to get rid of the 9. So we have only the x squared left is equal to 2 over 9. Ooh, this is going to be interesting. Now, again, we're going to square root both sides, and you're going to get x is equal to, well, plus or minus, don't forget the plus or minus. And then we don't know what the square root of 2 is, right? So we're going to leave that as square root of 2. But we do know what the square root of 9 is, right? That's just 3. Okay, and then we're going to just leave it like that. That's going to be our answer. All right, and for the last one, we're just going to add 80 to both sides. X squared is equal to 80, and square root both sides, so we get x equal to plus or minus square root of 80. Now, I'm like, 80, that seems like a big number. Let's see if I can simplify that, because all these other ones, like I know like the square root of 2, I can't simplify that. All the other ones we did simplify. It just simplified to be a regular number, right, without the square root in it. So we're going to go 80. What goes in 80? Well, 2 goes in 80. Don't say 4, because 4 is not a prime number. So 2 goes in 80 40 times. Ooh, and 2 goes into 40 20 times. 2 can still go into 20 10 times. And 2 goes into 10 5 times. Now we finally have something different. 5 goes into 5 1 time. So do I have any perfect squares? Upper dues 1 2. So what do I do with these guys? Right, we're just going to multiply them. So 2 times 2 is going to be 4 root 5. So remember that it's going to be literally square root of 80 is equal to 2 times 2 times 2 times 2 times 5, right? And so these two guys are perfect squares, and these two guys are perfect squares. So what do we actually end up with? Remember the square root of 2, this is going to be 4. This is going to be 4. This is going to be 5. Remember, we're still multiplying these guys. So what is the square root of 4? 2. What is the square root of 4 again? 2. So remember, we're multiplying. We're just bringing those down. And we're going to multiply that by the square root of 5, because that's not a perfect square. We're going to leave it at square root of 5. So what's 2 times 2? That's 4. That's why we multiply them. All right, so this is going to be our answer. So this is going to be x is equal to plus or minus 4 root 5. This is the answer I want. You're not wrong with square root of 80, but you always want to simplify. That's going to be what we want to do. All right, and so here we have, rewrite each quadratic function as 2 linear factors using what you know about the difference of squares. So remember about the difference of squares, right? So we're going to use the zero product property to solve, right? So I'm going to ask myself, well, first set this equal to 0, because I know I'm going to find the solve for x here. So one's going to be a minus and one's going to be a plus. That order does not matter. All right, so how do we get the x squared? Remember the first two, the two numbers, to two terms have to be x and x. X times x is x squared. How do we get the 49? 7 times 7. Remember, those numbers have to be the same. Not that you could find any other numbers anyways. You wouldn't do like 1 times 49 because then the middle terms don't cancel out. Excuse me. And then we're going to set this, remember the zero product property? The more I say it, the more you're going to remember. So remember, we're going to set, if it's equal to 0, which we are setting it equal to 0 because we want to know what x is equal to for these cases. So we're going to set both of these. So x minus 7 is equal to 0. Actually, it doesn't say that. We should solve for it. So we're just going to leave it at that. I was being too ambitious, but that's what we would normally do. All right, we're just rewriting them. There you go. That's it. Oh, I should probably take out the 0 too, because that should just be f of x, because we're just rewriting them. Oops. All right, so, but later on, we're actually going to have to solve for them. So this one, again, this is going to be a little bit harder because I see fractions, and one's minus and one's a plus. Well, I'll start with the easy part. Well, what times what is a 1? 1 times 1. I'll take that. And then I know since I have an x squared here, that I'm going to have x's on both of them. Now, how do I get 4 9s? Like, well, I know that 2 times 2 is 4, right? And then 3 times 3 is 9. So these are just going to be 2 over 3. There we go. So that's going to be, that's what that's going to look like in factored form. And the same thing with C. Let's set this up. We'll do plus here, no minus here, just to change it up, right? Oh, okay, that second one looks a little weird, but let's do the first one. So we know, well, this is going to be x and x. And 6 to get 16, that's going to be 4. So 4 times 4 is 16. But how do I get this 10? Well, here's the trick. This is going to be square root of 10. Because what do we know? What's square root of 10 times square root of 10? Square root of 100, right? Well, what's the square root of 100? 10. See? So it works. So when in doubt, just put them in square roots. All right. And then this one right here. Oh, this is not a difference. So we technically can't do this. So we're going to just leave this one blank. We'll talk about this in a bit, but we would later on, we will be able to do these ones, just not right now. Because this is not a difference of squares, right? This is a sum of squares, but we don't have that. There's no such thing as that for us right now. All right. So explain how to write any function in the form of x squared plus minus c. Okay, so well, what did we do? So we wrote down f of x, right? And we wrote down the two parentheses. We know how to do that. And one of them was a minus and one of them was a plus. And the x squared we know how to do because it's x and x. But what do we do with that a? Like, what was that number? Like, if it was a number like the 16 right here, right? Well, what did we do to get 4 and 4? Well, it's going to be the square root, right? So this is literally just going to be the square root of a and the square root of a here. Well, how do we get the c? We ask ourselves, well, what times what will give you c, right? So just like how we did for c, we're going to, literally c. We're going to do that to this c. So square root of c and square root of c. Ta-da! I know it seems more complicated when you write it like this, right? Now we feel so smart. All right, I will talk to you later. Bye.